I'm taking, let's say this frequency is 5, this frequency is 4, and this frequency is 3. So how will I plot it? So I choose an axis, right? Then this is my 0, and this is my, let's say 10, then I have 20, 30, 40, 50, like that. Okay. Now if I choose it 1, 2, 3, 4, 5, just try to understand. We will do questions after that. So 10 to 20, that means 10 to 20, the frequency is 5, right? So we make a bar like this. Next is 20 to 30, frequency is 4. So the next bar will be like this. So in this case, as you can see, there is no gap between the bars. Is that clear? This frequency is 3. 30 to 40, frequency is 3. So histogram will look like this. Is that understood?
Yes, ma'am.
Okay. And next also frequency distribution. Now, what is a frequency polygon? What is a frequency polygon? See, frequency polygon can be drawn two-way from histogram also. First of all, you can draw a histogram and then you can draw it, or it can be drawn independently also. How? What we do is, for a frequency polygon, now try to understand. We take the middle value. For example, the class interval is 10 to 20, right? So on the graph, you can see the middle value will be 15, right? So we can mark 15 here, make a dot. Clear? Okay. Then next 20 to 30. So you can see the middle value, which is 15, obviously. So at 15, you can mark a dot, right? 30 to 40. So middle value will be 35. So you can mark a dot at 35. And then you have to join it. So it will be dotted, 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 dotted. Now there's a problem. How will you join it to the axis, right? One minute. Zainab is trying to join. Yes, Zainab, can you hear me now?
Yes, ma'am.
You are again late in the class, Zainab.
Sorry, ma'am.
Anyway, I'm discussing what is a histogram and what is a frequency polygon, okay? Okay, now pay attention. So as I told you, just let me revise. Before this, we were doing bar graphs, okay? So in bar graph, there was a data which is of this type. Just try to understand, some items can be given or something can be given. So it can be like apple, mangoes, that kind of data, and the corresponding frequency, right? So this is how a bar graph look like. I mean, these items are independent of each other. They are not linked to each other. So apple is a different thing, mango is a different thing. So it looks like this. Now, if your data is continuous data, so as I've written, histogram is used for continuous class intervals. So if your data is like this, for example, you have a class interval 10 to 20 whose frequency is 5. See, this is just to explain you. We will do questions later on. Then the class interval 20 to 30, frequency 4, then 30 to 40 has a frequency 3. Is that clear?
Yes,
If you
ma'am.
want, you can include next also, whose frequency, let's say, is again 5, right? So the next will be in your graph. Sorry. Yeah, here. So 40 to 50, this is again 5. So this is how it looks like. So as you can see, there is no gap between the bar here. So that is the difference between bar graph and histogram. Okay. Now I want to draw a frequency polygon. Now try to understand what is a frequency polygon. So for frequency polygon, you actually need mid values of class interval. Right? This thing you need. And this mid value of class interval is actually called class mark, right? Now try to understand. I'll write everything later on. Now see here. So 10 to 20, the mid value is 15, right? So you'd make a dot of 15 here. Then 20 to 30, the mid value is 25. So there's a dot of 25. Then this is 35 and the mid value will be 40 to 50 is 45. So this is, and then you have to join all this. But this is incomplete, right, Zeba? Jesslyn?
Yes, ma'am.
Okay. Now to complete the polygon, what we do is just before this 10 to 20, we take an imaginary class interval. So what do you think? The gap is actually 10, 10 to 20, 20 to 30. So before this, the class interval has to be 0 to 10. Is that clear? Right?
Yes,
Now, what will be the mid value of 0 to 10? That will be 5. So we mark the mid value and also we take the frequency to be 0. That means this is an imaginary interval which does not exist. I mean, the frequency is 0. There is no value corresponding to it. Understand? So on the y-axis, it is 0. That means it's going to lie here only on the x-axis, right? Similarly, from 50 to 60, we can take an imaginary interval whose frequency is 0 and the mid value is 55, which will fall here. So then we join this polygon to this mid value like this. So this is actually a frequency polygon, which you can see a red color, right? So as I told you, there are two methods of drawing it. Either after drawing a histogram, you plot it, or without drawing a histogram also you can plot it. How? If I use the same data, let us explain. So I took these 10 to 20, the frequency I took 5, 20 to 30, I took 4, then 30 to 40, then we had how much? 3, and then 40 to 50, I have 5, right? That's my data. So this is the frequency. This is class interval, right? So I don't have a histogram. I just want to plot frequency polygon. So as I told you, you have to find the mid value of the class interval that we call class mark. So first of all, note the formula for class mark. So this is upper limit and minus lower limit and then divided by 2, right? See, this is nothing new. I mean, this is common sense. Now see here, I want to find the mid value of 10 to 20, right? Now I know it will be 15, clear? Right? Now please say yes or
yes,
no. Yes, I know it will be 15. So how will I get that 15? I simply do 10 plus 20 and then divide it by 2. So I get 30 divided by 2, which is 15. So this way I can find the mid value. So that's the formula you can use, upper value minus lower value divided by 2. Right?
yes, ma'am.
Okay, sorry. By subtraction also you can find, there's no issue. So upper limit, sorry, it should be plus. Use the plus. So upper limit plus lower limit divided by 2. That will give you. Right, this is class mark. So we make 3 columns. One is class interval, next is frequency, the third column we make for class mark, right? So class mark we calculate one by one from this formula. So 10 to 20, so I'll get 15 obviously. 20 to 30 will give me 25, 30 to 40, 35, 42. That you can check from formula also, right? So I've got the class mark. How to plot the frequency polygon now? So just a rough sketch. So this is the interval. Let's say 10, then 20, 30, 40, 50, 60. It's like this. This is 0. And then you take 1, 2, 3, 4, and 5, right? So 10 to 20, the class mark is 15. So I don't want to draw histogram. I want to draw frequency polygon. So you see here. So in the interval 10 to 20, class mark is 15, right? And the frequency is 5. So you have 15 here and the frequency is 5. So you make a point here. Clear? Next, class mark 25, the frequency is 4. So you have 25 here and the frequency is 4. So here it lies, right? Next, the class mark is 35, frequency is 3. So here it lies. Then 40 to 50, again, frequency is 5. So 45 and the frequency is 5. So it is here. So this is you obtain after joining it. So again, you have to take the imaginary class interval whose frequency is 0. So that means the point will lie here. Is that clear? So you join it. And before this also, the imaginary interval is 0 to 10, whose midpoint is 15. So class mark, whose frequency is 0. So it's going to lie here. And then you join it. So this is how your frequency polygon looks like. Is that clear?
Yes, ma'am.
So let us do question number 4 now, which is on histogram. Anyway, how was your marks in your half yearly exams? Has anybody got the marks?
No, ma'am.
So the length of 40 leaves of a plant are measured correct to 1 millimeter, and the obtained data is represented in the following table. So this is length in millimeters, as you can see, right? So 118 to 126, this is your class interval, and this is the corresponding frequency. Draw a histogram to represent the given data. Now there's a problem here. Can you spot the problem?
Ma'am, it's not continuous.
Exactly. So as I told you, histogram is for continuous data distribution, right? And this data is not continuous. So 118 to 126, then it is from 127. So there's a gap. Can you see that? So step 1, make the data continuous. How will you do that? So as I told you, if you have this kind of data, so we add 0.5 in the upper limit, right? And we subtract 0.5 from the lower limit. So the step is subtract 0.5 from lower limit, right? Sorry. And then add 0.5 to upper limit. Is that clear? This we discussed in the introduction part, right? Okay. So how will it look like now? You have to make a new column. So this is your length in millimeters and then number of leaves, which is frequency. Now the lower limit is 118, right? So I subtract 0.5. What does it become? It becomes 117.5, right? Then I add 0.5, so 126.5. Is that clear? Corresponding leaves are 3. Next, so 127, I subtract 0.5. So it becomes 126.5 minus, I add 0.5. So 135.5. This is 5. Again, I subtract. So it becomes 135.5 to 144.5. This is 9, right? And after that, I subtract. So that becomes 144.5 to 153.5. This is 12. Then you have 162.5, 171.5, right? Okay. No, I have missed one, I think. Yeah, sorry. So next is this. So it will become 153.5 minus 162.5. It will become. This is 5. Next is 163 to 171. So 162.5 to 171.5. And this is 4. Next is 171.5 to 180. That means 180.5. This is 2. Now, is this understood by everyone?
Yes, ma'am.
Now, can you see it is a continuous data? So 126.5, and then again it is starting from 126.5. So there is no, this is data is continuous now, right? So these are the steps which you have to remember. Please note them down. These are the steps. Okay, written so far? Yes, written.
Yes, ma'am.
Okay. Now please see. Your frequency is maximum 12, right? So 0 to 12 you have to show on the y-axis. And length. So it is a starting from 117.5 and maximum 180.5, right? So what is the method of plotting it? Just see here. You choose your axis. So here I'm taking number of leaves, and this side I'm taking length, which is in millimeters. So I have to plot up to 12 this side. So I can take intervals of 2, 2, right? So this is 2, 4, 6, 8, 10, 12, and 14. Is that clear? Okay. Now in your data, if you can see, the lowest value is 117.5. The highest is 180.5, right? Now how to plot it? So you don't have to start from 0 here, right? So you can start from the lower interval, which is your 117.5, right? Then at the gap of 2, 2, you can take the next, which is 126.5, right? Then you can take next, which is 135.5. Here you can take 144.5, 153.5, then 162.5, 171.5. Have I missed anything? 117, 126, 135, 144, yeah, 153, 162. Sorry, this is 162.5. Okay, right? So your interval is 117 to 126.5, 126.5 to 135.5. Can you see that on the x-axis?
Yes, ma'am.
Now, there's an additional thing you have to do here. Now, because you are taking a gap, I mean, this is 0 on the y-axis, right? But on x-axis, it's not 0. So you will make a cut like this when you draw the line. So that means some value where the data does not exist. So we are not plotting it. We are just shifting the x-axis for these values only, which are visible. Okay. See, try to understand it this way. For example, I have something like this. Let me say my data starts from here. Let's say 40 to 50, right? Then 50 to 60, then 60 to 70, and like that, right? Now, if I plot a histogram and I start like this 0, 10, 20, 30, 40, 50, 60, 70, like that, right? So basically, my histogram is going to start from here, isn't it? Something like this or something like this, right? That means this much like this is all wasted space. Is that clear? I don't have to show it. So what I can do is I can just shift my x-axis here. So instead of drawing the y-axis here I can draw the y-axis here itself. This is my y-axis, right? And then I mark a cut. That means I have omitted this part. Is that understood?
Yes, ma'am.
Okay. Because this space is anyway going to be empty, so I don't need to show it. I think now it becomes simple. So from 117 to 126.5, the frequency is how much? 3, right? So 3 will lie here at the midpoint. And the next is 5. So 5 again, here it will lie. See, you have to use proper graph paper for all this. In the test, you did on the rough copy, but in the exam, it will not be accepted like that. Okay. Next is 9. So it's going to lie here. Then you have 12, right? Next is 12, which will be here. Then next is 5, which will be here, right? Then next is 4, which is here. And the next is 2, which is here. Now please join it. So this is how the histogram looks like. Yeah, please let me know if you have drawn it.
Yes, ma'am.
Okay, let us come to questions now. First part we have done, draw a histogram. Okay, second, is there any other suitable graphical representation for the same data? So 3 type of graphical representation we know. One is bar graph, second is histogram, third is frequency polygon. Okay. Bar graph obviously cannot be drawn because this is a continuous data. Okay. So the second suitable is frequency polygon. right? You can write the complete sentence that the other suitable graphical representation for the same data is a frequency polygon. Next, is it correct to conclude that the maximum number of leaves are 153 long? What do you say about this, Jesslyn? Third part. Is it right or is it wrong? Zeba, what do you say about this? Zainab, what do you want to say about this third part? No response. Either say, ma'am, I don't know. Ma'am, I'm not able to say. Say something, please.
Now I don't know.
Okay. See here, they are saying that is it correct to conclude that the maximum number of leaves are 153 long? Okay. So they are saying that the maximum number of leaves are 153 Now, what is the height, maximum height? 12, right? So for a certain length, the maximum leaves can be 12. But this 12 is not only for this length, it is for a range of length, isn't it? It is starting from 144, 144.5 and up to 153.5. I mean, in this whole range, the frequency is 12, right? So that means all the 12 leaves are not necessarily 153 long. It can be 146 long also, right? It can be 150 long also. It can be 152 long also. So we cannot say that all the 12 leaves are 153 Is that understood?
Yes, ma'am.
Okay, so no, because the number of leaves are maximum. Uh, in the interval 144.5 to 153.5, right? But this does not mean that each leaf is 153 in length. Yes, have you done? See, the following table gives a lifetime of 400 neon lamps. So data is already continuous, okay? 300 to 400, 400 to 500, and number of lamps are given. So draw a histogram. First part, represent the given information with the help of a histogram. So this one is easy. Okay, so here we will take number of lamps, and this side we take lifetime, which is in hours. So number of lamps are starting from, I think lowest is 14 and something 86 I can see highest. So I can take an interval of 10, 10, 10, 20, 30, 40, 50, 60, 70, 80, 90. I think I'll be able to locate, right? Okay. Now your class interval starts from 300. Okay. It's going up to 1000. So obviously you have to make a break here. So make it like this. Okay. Or you can start from here. So this is your 300. Then you can take 400, 500, 600 here. Then this is your 700, 800, 900 and 1000, right? Okay, so 300 to 400, you have 14. So 300 to 400, the frequency is 14. So 14, you can easily locate on the graph paper because there are 10 lines between 10 to 20, right? So you just count 1, 2, 3, 4. So 14 will fall somewhere here. So this is the first bar. Then you have 56 next. 56 will be somewhere here. Next you have 60. 60 is exactly here. Then 86. So 86 will fall here. $74. Okay, so somewhere here, 74. Then you have 62. So it will be here. Then you have 48. So this is how it's looking. And make proper lines with the help of a scale. Straight lines, okay? Yes, have you drawn?
Yes, ma'am.
Okay, second part. How many lamps have a lifetime of more than 700 hours? So more than 700, right? So, okay, now in this interval, if I talk of, so you have to take more than 700. Okay, so 700 is obviously not counted in this interval. So you have to take from the next interval. Okay, so in this interval, 700 to 800, the frequency is 74. Or you can see here also, it is 74, right? The next you can see this is 62 and the next is 48. So this will be 72, sorry, 74 plus 62 and plus 48. So this will be 6 and 8, 14, carry 1, 14, and then 4, 184. So 184 lamps is the answer. Yeah, have you done? Zainab, have you done?
Yes, ma'am.
Zeba? Jaslyn, have you done?
Yes, ma'am.
Okay, next. The following table gives a distribution of students of two sections according to marks obtained by them. Okay, represent the marks of the students of both the sections on the same graph by two frequency polygons. So you have to draw frequency polygon on the same graph. Okay, from the two polygons, compare the performance of the two sections. Okay. So for frequency polygon, what you need, I told you, class mark, right? So first of all, we will make a column of class mark. So again, you make your table like this. You can make separate tables also, or in one table itself you can make. So let's say this is your section A and this is your section B. If you don't have space, you can draw it separately, no problem in that. So then you have to divide this into three parts. One is your marks, which are actually given, right? Then you will calculate class mark. So this mark and class mark are two different things, okay? And then frequency. Similarly, you will write the marks of students, then you find its class mark and then frequency. Okay, so what are the marks of section A? So I use different color pens, okay? Blue is section A. Okay, 0 to 10. Then frequency is given, which is 3. Then you have 10 to 20, frequency is 9. Then 20 to 30, frequency is 17. 30 to 40, it's 12. See, for frequency polygon also, you have to use continuous data only, right? You will convert otherwise in continuous data. Now you find class mark by using the formula upper limit minus lower limit, plus lower limit divided by 2. So 10 plus 0 divided by 2, which is 5. See, in such kind, you can directly write, you know what is the mid value. 10 to 20, it will be 15. Here 25, here 35, here 45. Is that clear?
Yes,
Okay.
ma'am.
Then I use some different orange pen, let's say, for this, or green pen for this. So marks are same. 0 to 10, 10 to 20, 20 to 30, 30 to 40, and then 40 to 50. And obviously the class mark will be 5, 15, 25, 35, and 45. It's 5, 19, 15, 10, and 1. So this is the corresponding frequency given. Now same graph paper you have to plot it. So the class interval is it's starting from 0 up to 50. And then frequency, I think maximum I can see 19, right? Okay, if I take an interval like this, 0 and then this is 4, right? So somewhere you will get an interval like this. Okay, so 0, then 4, then you have 8, 12, 16, then next will be 20, right? So if you have an interval 16 to 20. So can you spot 19 here? So basically this is 20 minus 16, which is 4, and this 4 is actually divided by 10 parts. So this is 0.4. So the one interval is actually 0.4, right? So not 0, this will be 16.4, like that. Uh, okay, then leave it. I think you will get confused. Let me use a simple scale. So on this side, you will take marks, and this side, you will take number of students or frequency, right? So first is 0 to 10. So if I take this 0 and I take this 10, 20, 30, 40, 50, 60, that's it. Maximum yards 40 to 60. So in that case, you have so much of a space. So you can do one thing. You can further extend this. You can take like this at an interval of 4 if I take. So 10, 20, 30, 40, 50. Yeah, okay. So this is 10, 20, 30, 40, and 50. Is that clear? Okay. Now number of students are, my data has to go up to 20 at least because my one value is 19. So how will I plot it? I think if I take 2, 4, 6, 8, 10, then 12, 14, 16, and 18, and then next 20. I think this much you can show on your graph, right? So I'm just writing here because it's not visible. So 10, this is 20, 30, 40, and 50. Okay. If you want, you can take at an interval of 2, 2 also. Is that clear? You can take your 10 here, then you can take your 20 here. That way also you can take. There is no issue. Is that clear? It's all your wish. Right. So let us start with blue color, section A. Let us plot it. So the first class mark is 5 and the frequency is 3. So it will lie here, right? This is the point. Next class mark is 15. The frequency is 9. Class mark means middle value 15 and this is 9. Next is 25 and 17. So 25 and it will be 17. So that means here, right? Next 35, it's 12. So for 35, it is 12 here. And for next 45, it's 9. 45, it will be 9. That means here, right? Okay. So you join it with the help of scale, proper lines you have to draw dotted or at least show this points, right? Like this. And you can use dotted lines. Now, this is incomplete as I told you, isn't it? Now come here. I have to touch it to the x-axis. Is that clear? How will I do it? See, my first, try to understand everyone. In my data, my first interval is 0 to 10, right? And this is my 0. So that means if I use an imaginary interval, so it will be from 0 and here minus 10, isn't it? If I just extend this line. Is that clear? Yes?
Yes, ma'am.
Yes,
Okay.
ma'am.
So you have to show this on your graph paper, this minus 10. And what will be the middle value of this? Obviously this minus 5. So you will, whose frequency is 0. So you will show it on the x-axis. So this is the point where this polygon is going to touch. Is that clear? Okay. Similarly, come to the extreme end, right end. The next interval is obviously here you have 50, then 1, 2, 3, 4. So here you will be having 60, right? And what will be the mid value? It will be 55. So here is a point whose frequency is 0, the class mark, and then you will join it at this point. So this completes the frequency polygon for section A. So you will write something like this. You'll make a line from blue pen and write section A, right? Now I want to plot section B. So you make a line green and then you write section B. That means green line will represent section B, blue line will represent section A. So on the same graph, let us plot section B also. Okay, so 0, class mark 5, frequency is 5. So this is 5. Now 15, the frequency is 19. So it will be here. Then 25 is 15. 25, then you have 15, which is here. 35 is 10. 10 is here. 45 is 1. 45 is 1. That means here, right? Okay. So you will join it with the help of scale with dotted lines. And the same thing, next imaginary interval from 50 to 60, whose midpoint we have already marked. So you join it here, right? And similarly here you have to join it. Please use straight lines like this. Okay, done. Zainab, done.
Yes, ma'am. Done, ma'am.
Now, there's a question here. Uh, it is given from the two polygons, compare the performance of the two sections. Okay, so by looking at it, what can you say about the performance of section A, section B? Which section performed better? Zainab, what do you say? Say anything, you feel, then we can discuss. Which section has performed better, section A or section B, according to you?
Section A.
A, why?
The green one.
Okay, green is section B, right?
Yeah, B.
Okay. Zeba, what about you? Green or blue? Jesslyn, what about you? Yes, Jesslyn, what do you think? Green line is better performance or blue line? Hmm?
The green line has better
Green.
performance.
Okay. Now pay attention. See, both of you are wrong. Why? See, you are thinking that green line is higher here at this point, right? So you think the performance is better, right? That's the reason? No, that's not the reason. Why? Now see, here what you have marks on this x-axis. Is that clear? And these are just number of students. Now, if you see the green line, now what is happening? Uh, many students, like up to 19 students, you know, they are getting marks between 0 to 15. Can you see that? And after that, 20 to 30 marks, like somewhere between 20 to 30 marks, less number of students are getting. But in class A, between 20 to 30 marks, more number of students are getting it, isn't it? And as the marks are getting higher, if you look at this interval, 40 to 50, right? From 40 to 50 in green line, that means only two students have got marks between 40 to 50 in section B. Can you see that?
Yes, ma'am.
But in section A, the frequency is how much? It is like, I think 9. So 9 students have got marks between 40 to 50. That means as the marks are getting higher, in section A, more number of students are getting it. So between 40 to 50, section A, 9 students. Section B, only 2 students, right? Now between marks 30 and 40, in section A, 12 students are getting it. And section B, 10 students are only 10 are getting it. Now 20 to 30, here also 17 students are getting marks in this range, and here only 15 students are getting. Now between 10 to 20, so here 19 students are getting, and here only 9 students are getting. So when the marks are very low, between 10 to 20, then 19 students are getting in section B. But when the marks are higher, then more number of students are getting in section A. I hope it's understood now.
Yes, ma'am.
Yes, so the performance of section A is better. See, graphs are not that simple. You have to analyze the whole picture here, okay? Don't look at the height. You have to understand the meaning of this graph. Okay, then how many questions are left now in this exercise? So sixth we have done, seventh, eighth. Yeah, okay. I think in the next class we will be able to complete this. And measure of central tendency is not in your syllabus. So